Hello, welcome again. Yes. I am Trinity, the tutor of the tribe of TRiCiTY. Okay, now we have something interesting today. We want to talk about Hooke's law, elasticity, and all you have about that. Yeah, a student asked me a question concerning elasticity and Hooke's law. She explained she experiences challenges in solving questions concerning Hooke's law, young modulus, and all about that. These things are so simple. All right, I'm liking this. Okay, so let's check my notes here. Now, this is a question. Okay, let me just start with this. Let me start with this first. Can you solve this question? Can you solve this question? A springboard, did I call it a springboard? A spring has a spring constant K, which is 20 Newton per centimeter. What load is needed to produce an extension of 2.5 centimeter? Now, the first thing you need to understand is that when you see questions like this, questions that has to do with extension, spring constant, and all this, you should know that Hooke's law is being involved. All right, so you have Hooke's law being involved. What should come to your mind is elasticity when you see questions like this. But before we go into this, let's look at something interesting. In our everyday life, elasticity is applied in our everyday life. All right, you have your rubber bands, bungee jumping. All right, you can check this up yourself. You have springs, even in your body, your muscles employ elasticity. Yeah, they employ elasticity. You can read it up. Even your clothes, sometimes you wear clothes that are elastic. You wear hand gloves, you wear rubber shoes that are elastic. You have springs that are also elastic. So solving this kind of question is you actually bringing your everyday physics, expanding it, and getting more details of material and objects around you. To solve a question like this, all right, the first thing you need to know is that when it comes to solving questions that has to do with elasticity and Hooke's law, you should always bring out your parameters. What is your force? That is the first question you should ask. All right, what is your extension? That's the next question you should ask. All right, and what is your constant? That's the next question you should ask. All right, so then you look at your question. Do I have this in my question? Okay, in my question I have spring constant. Okay, so I come here and I write it. Spring constant what? 20 Newton per centimeter. Okay, do I have my extension? All right, it's here. What do I do? I write it out. All right, 20. Sorry, that's 5 rather. All right, 2.5 centimeter. Okay, then what else? My force. Do I have my force? I don't have force here. I was only asked what load is needed. What load is needed? My load is my force. All right, the load is missing. Do you understand? So in solving this further, this is the formula for solving elasticity. Your force is your F, your K is your constant, and your E is your extension. Do you understand? All right, so our force is missing, so we could just write our force as F equals to our extension, which is our extension multiplied by our constants, which is what? 20 multiplied by 2.5, which gives us 50. But you don't just write 50 as the answer. Force is measured in what? Newton. So to get your full marks in class in high school, you need to put your units. Most of you guys just solve, like you could just solve and you don't put your units. That's wrong. You have to include your units. So this is your answer. Is that simple? That is your answer. Now, if you find difficulty in solving this question, it could just be that you don't understand elasticity. So now, let's explain what elasticity is. Elasticity is a very simple concept. And when you're talking about elasticity, it's basically about you, playing with the ability of a material to expand and pull back. All right, let me show you this. You see this rubber here? You see this rubber here? When you actually pull this rubber, can you see? That rubber expands, right? And when you let it loose, it goes back to its original shape. That's what you're doing with elasticity. So you realize that the more pressure, the more force you apply to the rubber, the more the rubber stretches, right? And when you take out the force and the pressure, the rubber goes back to its what? To its original shape. So Hooke's law tells us that. All right, Hooke's law, right? Okay, where's Hooke's law? This is Hooke's law. Hooke's law tells us that the amount of force which you apply to an elastic material is directly proportional to the extension of the material. All right. Okay, now let me write that out for you here. Hooke's law. All right. Says you don't need to put, like, you don't have to cram this. It's just easy. It just says that the amount of force, all right, you apply to an elastic material is what? Is equal to the what? The extension of the material. Yes, Hooke's law tells you that the amount of force you apply to an elastic material is equal to the extension of the material. So you have to understand that force is the same thing as tension here. The same as what? The same as tension. Do you understand? And extension is what? Is the same thing as is what? It's the same thing as increase in what? In length. All right. So we have what? Our extension, and we have our force, right? Your force is your tension, your extension is what? Your increase in length. Get that right. So once again, Hooke's law is saying that the amount of force or the amount of tension you apply to an elastic material is equal to the extension of the material. Now, all this makes sense under one condition. Under one condition. And this is his condition. Now, if you observe, this same rubber, it gets to this point where you keep on stretching it, or if you have an elastic material, or let's say an elastic cloth, or something elastic, you keep on stretching it, and it gets to this point whereby it doesn't come back again to its original shape. You've stretched it and you've overstretched it. You've applied too much force and pressure, and guess what? You spoil the shape of the material. It's deformed, it's spoiled. It can't come back to its original shape. You say, oh, this rubber is bad now because why? It's no longer, you can't stretch it any longer. It's spoiled. At that point where you've overstretched the rubber band and it cannot return back to its original shape, whereby you spoiled it, you have reached what is called what? The elastic limit. The elastic limit. The elastic limit. So elastic limit, that's what you see here. The elastic limit is that point where elastic limit is that point where the material can no longer return to its original shape. So as long as you do not reach the elastic limits of any elastic material, Hooke's law will always come out to be true. What are we saying? Let me create another page here. Okay, so we are saying that Hooke's law is what? The amount of force you apply to an elastic material, and it is equal to the extension or the increase in length of the material, right? Now we are saying now that this is true as long as you do not reach the elastic limits of the material. You know that when you play with rubber, you keep on stretching it, it goes back to its original shape. As long as you do not apply too much force to the extent that it gets spoiled, it will always return back to its original shape until you spoil the rubber band by applying too much force. Do you understand? All right. Okay. So as long as the elastic limit is not what? Did I hear what exceeded? Or all right. Yeah, it is vital to know that as long as you do not pass the elastic limit or break the elastic limit or exceed the elastic limit of any elastic material, Hooke's law will always work out for you. The reason why I said 4 is because we make use of Hooke's law in our daily life. For example, your catapult makes use of Hooke's law. You have a catapult, you want to shoot something in the air. Hooke's law will always work out for you if you do not pass the elastic limits of your catapult. Do you understand? Right. So then how do you represent it mathematically? Is that you write your force. This is your force. Your force is your tension, remember? And your force is equals to your constant and your extension. All right. I'll make this video short. In the next videos, we are going to do more calculations. So let's check this out. The second question now. All right. So we see now that a spring requires a load, which is same thing as force, of 2.5 Newton to increase its length by 4 centimeters. The spring obeys Hooke's law. Can you see? What load, that is what force, will give it an extension of 12 centimeters. So how do you go about this? You write this. Now you see this. You come here and you write your formula, right? You write your formula. What you have here is this. Remember your formula is what? F is equal to KE. What's your force? Your force is what? 2.5 Newton. And your K, you're being asked what force, right? You look at, you were asked is, all right, now this is it. A spring requires a load of 2.5 Newton to increase its length by 4 centimeters. So your increase in length is what? Your extension. That's your E. Your E is what? Your E is 4 centimeters, right? Now, where's your K? We weren't giving K here. So I will just do this. F is equals to KE 2.5 Newton equals to, my K is not known, but my extension is known, right? My extension is what? 4 centimeters. What do I do here is I will divide both sides by what? 4. So I'll do this. All right. 4 cancel out. And what do you have here? Let's get our calculator. All right. Let's see what we have. 2.5 divided by what? By 4. And that gives us what? 0.625. So my force is equal to 0. No, not my force, rather my constant. All right. This is K is equals to 0.625. Now what's the units? How do I know the units? You have N here, right? And you have cm here, right? Remember that your cm is the 4. So you have what? Newton all over this. So your constant is what? Your constant is what? 0.625 Newton per centimeter. Right, so for now, this is the constant of the spring. It's always constant. It's always constant. All right. Now, the next question is like 2 questions in one. The load of 2.5, which is this, increases a spring by 4 centimeters. We're told that the spring obeys Hooke's law. So we found the constant for the spring. We are asked what load will give it an extension of 12 centimeter. I know that 2.5 Newton of force will increase the spring by 4 centimeter. If I want to know how many force or how much force will increase the same spring by 12 centimeter, I need to know the constants, which we just found now. Now that I know the constants, for the new force, force is equal to what? KE 0.25 multiplied by E. Remember, we want to find for 12, not for 4 now, not for 4, but for 12 centimeter. So I bring out my calculator again. 12 multiplied by what? By 0.625. What do we have? We have a force of what? 7.5 Newton. So that's our answer. This video is meant to be an introduction to elasticity and Hooke's law. So there's a lot for us to learn, a whole lot for us to learn. We still have to do practicals. I still have to explain a whole number of things here. I want you to like this page. I want you to subscribe to this channel. I want you to like this video as well. I want you to share this video to your friends and family. If you have someone who needs a home tutor for their kids, or you are a student in the home tutor, you can please contact my number via WhatsApp. You will find it in the description below. And pay attention to more videos. You can also get my notes. This notes is also in the link below. Thank you very much.